Hello, mentors. This is a quick overview of each gelateria. Let's start with Gelateria Prima. It has 4 flavors. You have to do a scoop, also have to do syrup, and you can be a cone or a cup. Scoop or syrup, they can repeat, so that's totally fine. But remember, the syrup is mandatory. Of course, students will maybe protest or say why. It's just much simpler to analyze this model, but you could ask them as a follow-up question, what would happen if syrup is just optional? The total number, it's 4 times 4 times 2, that's 32. And in general, it would be the number of flavors squared, and then you double it. It's similar to rolling 2 4-sided dice in order, and then flip a coin and just see how many results you have. Quickly, let's see a representation for these 32 here. How could we make sense of that? One is first, just forget about cone versus cup and just think about the flavors. So here you would have syrup and scoop, and these would be all possible combinations. Notice that the order matters. For example, this is a vanilla cream or syrup with chocolate scoop. It's different than a vanilla scoop with chocolate syrup. So these two gelatos, these two ice creams are really different. We want them to be different. So that's a real life discussion. That's how we want it, right? A person who orders that and they give you this instead will be protesting, will be saying, no, I really wanted this instead of this. And then we would time by 2 because it would be just 1 table for each of the flavors. Okay, Grom is the same, it's an extension. So Prima is a subset of Grom in terms of the gelatos. So that's some good observation. It has just 1 more flavor. Scoop and syrup is the same. You can repeat and it's mandatory. And then you can be cone, cup, but also a popsicle or a paleta, a lollipop. So you have 1 more option. So hopefully students have the same logic about the table, and there's going to be now 3 tables of 5 times 5, right? Things something like this, actually. And then it's going to be 5 times 5 times 3, so 75. So hopefully for students visiting this second gelateria feels a little easier, and they already know some rules, some intuition, and they can work faster here and use more abstract representations. So you wouldn't be surprised that they come to this formula much faster than they came to this formula. And it actually lets them relate them. So it's similar to spinning 2 different 5 sectors, spinners in order, and then one of 3 sectors. That could be an analogy. Okay, so these 2 first gelateria, they're really similar. Order really matters here because you have syrup and scoops. And now we get the following 2. So it's this is the second family. So what's San Lorenzo? We don't really care about the container. It's just cone. So we don't even draw it here. We could draw it, but combinatorically, it doesn't really matter because it's just 1 option. Whenever you are counting things and you just have 1 option in one of the aspects, you can just forget about it entirely because it's not going to add or subtract to the count. We have 5 flavors, and scoop both are mandatory. Here we have some nice representations that you could develop gradually with your students. XY means different flavors. XX would mean the same flavor. And that could be helpful to make sense of the combinations. Let's see how it looks like. So for San Lorenzo, it's the same table, but now we have scoop. Remember how in the first gelateria we had scoop and syrup? So the order was different. So we really wanted to count all these possible combinations here. Whereas in this San Lorenzo, we have scoop and scoop. So of course, somebody that asks for a vanilla and then strawberry is the same as strawberry and vanilla. So these 2 options would be exactly the same. They will never protest, hopefully, if the chocolate or the vanilla is in the bottom of the cup or of the cone, whatever, rather that is it on the top. They don't really care about the order, right? When you're human and ordering a gelato, your brain is just checking that these 2 flavors that you ask are there. The order doesn't matter. You're going to eat it any order anyway, so it doesn't matter. So we have had this table, but then we have to count the diagonal. So it's going to be like something like this whole table that's 25. You could just subtract this for now. So 20, then divide by 2, that's 10. And then you have to account for all the choices where somebody really like a flavor, right? Like chocolate, chocolate, or pistachio, pistachio, blueberry, blueberry. So you get a count here, and it's cool because you could also see it as a sum of a triangular sum of numbers that are just increasing, 1 plus 2 plus 3 plus 4 plus 5 in many different varieties, as you can see. So it's really, really different, this San Lorenzo. Similar to going to the store, buying 2 fruits from 5 possible types, let's say, and possibly repeating, right? You could buy apple, apple, or apple, mango, banana, apple, banana, banana. That would be the count. You would have 15 choices total. Finally, the hardest one, 100%. So we get one more flavor. Okay, that's not that bad, but we get now 3 scoops. So that really makes it more complicated, right? 3 scoops. And what's going to happen is, by this same logic, we could use a representation that it's more abstract, and we can call it a meta table. That's the name I came up with, or a meta list, sorry, not a meta table, but a meta list, which is just a list of the exclusive things that comprise your whole universe. So it's not a list of all the elements or the gelatos, but all the categories that are very useful, mutually exclusive. So they're totally separated, and they cover all the cases. Every gelato that you're going to count, it's in one of the categories, and you're not counting any gelato twice, only once, exactly once, so that later you can add just to get your final count. So with letters, it would be, okay, I'm buying a gelato of 3 scoops, and I have 6 flavors. No syrup or salsa, cone only, so I don't even need to draw it here. So the 3 really easy cases, more natural, would be all scoops equal. So I can call this X, 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 or same, same, same. The second case would be 2 scoops are equal, but the other one is different. So there's repetition, but not full repetition. And finally, everybody's different, right? X, Y, and Z. All the scoops are different. And if you read the teaching manual, the teaching guide, you'll see why there's 6 here, 30 here, and 20 here. So here we use more abstract representations. We could go back to a table whenever we want, or to these lists, etc. But this is a powerful representation, the meta list, because you're now working on a higher level, and you're like, okay, I know how to count basic things. Now you have a monster. You have a really harder problem, because, right, it's hard to get 3 scoops. It's like very, very, like a lot of things going on. But then you go like, okay, there's cases, right? I'm going to first count all the scoops equal, then this, and then that. And then, because you visited all the gelaterias in the past, you already know these rules, how they work, or they're easier. And then you get a count. You just add to get the final result. So that's the 4th one. Final thing about representations, even for the first one, you could also use a tree to represent this table as a tree. So this would be a 4x4, 16 choices. You could also view it as split into 4 to pick the scoop. And then once you pick the scoop, you pick the syrup, or the other way around. So the order matters, but the order of the tree doesn't matter. In other words, for example, this here would be flavor syrup vanilla with pistachio for the scoop. You would just find it here in the scoop for pistachio and flavor vanilla. So the order in which you build the tree doesn't matter, but the order matters between syrup and scoop. For example, this branch here, it's here. It's not the same as this one, because you're switching the flavors of scoop and syrup, and that's important for a human, right? When they eat. Here's a nice way about the tree that the table you couldn't really do, because you would have to be like 3-dimensional table somehow. So put kind of one below the other, like 2 layers. But with the tree, you can't. You just go to the right, and then you say, it's like the clerk asks you, do you want a cup or a base? Sorry, a cone or a cup? And then you make the choice. So for example, somebody that would like a chocolate cone, it's here, chocolate cone. But if I want a vanilla scoop with a pistachio flavor in a base, in a cup, I would be represented by this branch, the one that travels from here to here, all the way there. And you can really count these. Of course, you're not going to count one by one, but you're going to say, okay, it's 4. Now it's split into 4. So 4 plus 4 plus 4 plus 4, that's 16. But each of these guys split into 2. So that's 16 times 2. So it's 32. So it's multiplication at heart, right? What we're doing here. So in another video, we'll actually take a look at the questions and the secret menu for each of the categories. But this video was just an overview of the 4 gelaterias. So in a nutshell, it's 2 families. The first 2 are similar, and then the last 2 are also related combinatorially. Okay, so I hope you enjoyed this video and see you in the next one. Bye.